Today we are going to demonstrate the working of Prony Brake dynamometer. Going to the introduction part, a Prony brake uses friction between a brake block and a rotating drum to measure torque. Two spring balances or force indicators measure the tension on either side of the lever. The difference in tensions and lever arm gives the braking torque. Torque speed and speed give the brake power. The apparatus required are engine or motor with rotating drum, Prony brake assembly, brake shoe, lever arm, two spring balances or one spring balance plus known weight, tachometer to measure the speed in RPM, vernier or ruler to measure lever arm length, weight for calibration purpose, stopwatch. Here we can see the figure of a Prony brake dynamometer. Right? There is the torque arm at the top. Then we have provided the brake block which is covering the engine shaft or flywheel. Then there are weights provided for the torque arm for the balancing purpose. As the rotational motion takes place, the vibration creates unevenness. To balance that, we have provided weight at the one end of the torque arm. Now moving to the experimental procedure part. Mount the Prony brake so its brake shoe presses on the rotating drum attached to the engine shaft. Fit the lever arm to the shoe and attach the spring balances at the lever end. Start the engine and run it at a slow steady speed. Note the reading using tachometer. Gradually increase the speed to a required steady value. Read the two spring balances F1 and F2. Ensure readings are steady. Measure the perpendicular distance L from the shaft axis to the line of action of the resultant force, which is the lever arm length. Calculate the torque T. Calculate brake power. The conclusion for this demonstration is that the Prony brake measures torque by friction, which is torque into rotational speed gives brake power. It is simple and direct method to determine an engine output power.